learn. I'm going to show you method 1 today. So for your homework, you're going to do it using method 1. And then come Thursday, I'm going to show you method 2. And then after seeing both methods, you are going to decide which method you prefer. On the quiz, I am not going to say solve it by using method 1, solve it by using method 2. You pick whichever one you find works the best for your thought process. Okay? So, our first problem looks as such. So a complex fraction is a fraction that has a fraction in either the numerator or the denominator or both. So this would be an example of a rational complex fraction.
Yes.
Because my numerator is the fraction x plus 1 all over x. And my denominator is the fraction x minus 1 all over 2x. Okay. Now this is not any different than what we did in section 7.1, this specific problem. Because what's another way to write a fraction bar? As a division symbol, right? So can't I just rewrite this as x plus 1 over x divided by x minus 1 over 2x?
Yes.
Yeah.
And then you can
And doesn't that look exactly like what we did in 7.1? Sure does. So what am I going to do?
flip.
So flip the second one. So we get x plus 1 over x times 2x over x minus 1. Because I am multiplying fractions, we can reduce on the diagonal. Does anything cancel out?
Not yet.
Well, something will. What cancels? Well, just the x at the 2, right? My x plus 1 and my x minus 1s will not cancel out. Say it again?
For the x plus 1 and the x minus 1, the x's will still cancel, won't they? Or no?
Nope, you can only, because it's not multiplied, it's not a factor. So I'm left with 2 times x plus 1 in my numerator, and I'm left with just an x minus 1 in my denominator. Okay? So we can turn a complex fraction into just a division problem, bless you, and then we can turn the division problem into a multiplication problem, just like we did in section 7.1. So it's no different, it's just it's going to look different initially. Okay? Now, what happens if it's not as nice of something in our numerator or denominator? So here we have 2 plus 1 over y divided by 3 minus 2 over y. Okay. So now, before I put it to that division problem, I need to just have one fraction in my numerator, and I need to have just one fraction in my denominator, which we just learned how to add and subtract rational expressions in section 7.2. So I'm going to ignore the whole division aspect and just focus on my numerator by combining those together by adding them. The denominator of my 2 is a 1. So what's going to be the common denominator of a 1 and a y? Y. So I need both of my denominators to be a y, which means what do I need to multiply my 2 by? So multiply by y, so that becomes a 2y. And my 1 over y does not change. So what does this combine to make?
2y plus 1.
Good. 2y plus 1 over y. Good. Now we're going to do the same thing to, excuse me, my denominator. What's going to be the common denominator? Y. Good. So it's going to be a minus y. So what do I need to multiply the 3 by? A y. So then I get 3y over y minus 2. So what does that subtract to make? 3y minus 2 all over y. So now I have one fraction being divided by, a really bad division bar, one fraction being divided by another fraction. So now we can just do what we did in the last problem. Is everybody okay with me jumping to the multiplication part first, or should I write it out? I'll do the division. I'll write it out just in case. So we get 2y plus 1 over y divided by 3y minus 2 over y, which would go to 2y plus 1 over y times y over 3y minus 2. Anything cancel? The y's go away. So we're left with 2y plus 1 over 3y minus 2. Okay, so we're kind of combining both 7-1 and 7-3 or 7-2 together to make 7-3. We may have to add or subtract rational expressions to turn them into just one fraction in my numerator and denominator, and then use our thought processes from 7-1 to how to divide those. Okay, can I keep going? All right. So our next one gets a little bit more complicated. We got 2p plus 5 all over p minus 1 in my numerator. And then we've got 3p minus 2 all over p. All right, so let's think about my numerator first. Okay, if you feel like you need more space, you could possibly write it out like this. You could do 2p plus 5 over p minus 1 divided by 3p minus 2 over p. That feels like it gives you more space, then you can just work down instead of across. All right, so my denominator of the 2p is a 1. So what does this have that this doesn't have? The p minus 1. So that means I need to multiply by a p minus 1, bless you, for this fraction, both top and bottom. Do I need to multiply the 5 by anything? No, I mean we could multiply it by 1 if we wanted to, but we don't have to. So now let's go ahead and multiply this out. So I get a 2p squared minus 2p plus the 5 all over p minus 1. Okay, so now let's go over to this rational expression. So my denominator of 3p is 1. So what does the right fraction have that the left fraction does not have? A p. So we need to multiply by p on both the top and the bottom. So now we get, multiplying that out, 3p squared minus 2 all over p. All right, so those two are being divided. So we're going to turn it into multiplication and flip the second fraction. So my first one stays the same, times p over 3p squared minus 2. Is anything canceling out right away? Well, this has a p minus 1 attached to it, so I can't just cancel out the p.
Can't we factor out?
Yes, that's what I would then do. I would try to see if I could factor anything. So let's factor this top one. 2 times 5 is 10. Are there any factors of 10 that get us to negative 2? So we got 5 and 2, that gets me to 3. 10 and 1, that gets me to 9. So is that factorable?
No.
No. Can I factor this? No. So then what am I going to do? just write it out as multiplication. So I'm going to put the p in front, times 2p squared minus 2p plus 5, all over p minus 1 times 3p squared minus 2.
That's your answer.
That's your answer. So nothing will cancel. Huh? Did you say it does factor?
No.
Oh, okay.
You guys decimals then, we're not ever going to do that.
Right. Okay. All right. I want to do one more with you guys. And we'll be done. Oops. Did I get rid of that too fast? All right. So now what's going to happen is you may be given... Well, where's my negatives? Go away. Actually, let's save the negatives for later. I'm going to cancel one of your problems. Let's try this one out yet. I'm going to nix 29 from your homework. Deal with the negatives on Thursday. Yep. All right, so 1 over x plus 1 over y. And then 1 over x squared minus 1 over y squared. So if it helps, you can just rewrite it separately. So 1 over x over 1 over y divided by 1 over x squared minus 1 over y squared. So my common denominator for the first would be an x and a y, which means I need to multiply the first fraction by a y on the top and the bottom. And I need to multiply my second fraction by an x on the top and the bottom. So that gets me y plus x divided by, here I have an x squared, here I have a y squared, so I'm missing a y squared in the first. And I'm missing an x squared in the second. So then we have, y squared minus x squared all over x squared y squared. This factors to what? Good. Y plus x, y minus x. So if I flip it, so multiply x squared y squared over x plus y, or sorry, y plus x, my y's first. Y plus x, y minus x. Then we got a y plus x over xy. What starts canceling? Yeah, your x squared and y squareds are going to cancel out with the xy, so you'll just have an xy in your numerator. Your y plus x's are going to cancel, so you're left with just a y minus x in your denominator. Okay, so for your homework, you're going to try all these methods out. You're doing numbers 3 through 23, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them that you're going to try. Next number 29.